Hi guys, let us discuss Hamiltonian circuit problem in this lecture. What is Hamiltonian circuit problem? A Hamiltonian cycle or circuit is a path in a graph that visits every vertex exactly once and returns to the starting vertex, forming a closed loop. So a graph is said to be a Hamiltonian graph only when it contains a Hamiltonian cycle. Otherwise, it is called non-Hamiltonian graph. So Hamiltonian cycle means we start from the particular vertex and visit all the vertex only once and return to the starting vertex itself. Let us consider a sample graph with 6 nodes A, B, C, D, E, F, and the edges are as given in this diagram. So we should find the Hamiltonian circuit for the given graph. Let us start the solution with the root node. Here in this graph, I consider node A as the root node as per the alphabetical order and initiate the process. We have initiated solution considering node A as root node. Now let us find the adjacent nodes of root node A. The adjacent nodes of node A is B, C, D. B, C, D. Okay, you draw the uh, tree diagram like this because B, C, D are the adjacent to the node A. Next step is out of this B, C, D, as per the alphabetical order, let us choose the node B now and find the adjacent nodes of node B. So adjacent nodes of B are A, C, E, but we have given only C and E here because we have already visited A in this path already, because in the Hamiltonian circuit problem we have to visit the node only once. So out of A, C, E, we are given only C and E here because A is already visited. Similarly, out of C and E, as per the alphabetical order, let us choose the node C now and find the adjacent nodes of node C. So adjacent nodes of node C, listen here, A, B, D and E, isn't it? But I have given only D and E because A and B already visited in this path, because every node should be visited only once. So this is an important point we have to note down. So we have given only D and E here because these two nodes are not visited already in this path. So that is why I have given only D and E as adjacent nodes to C. You may have a doubt that node E already comes here, but again I have included here. The reason is, when you consider this path, we have to take into account only whether the node is visited in this path only. So the E visited here but not in this path. So that is why I have included E here. Again, out of node D and E, as per the alphabetical order, let us choose the node D now and find the adjacent nodes of D. Adjacent nodes of D, C, A, E, F. So all these nodes are adjacent to D, but C already comes here, A already comes here, so you put E and F. So these two nodes are not appearing in this path from A to B, B to C, C to D. So that is why I have given E and F here. Out of these nodes E and F, let us choose the node E as per the alphabetical order. If you see the adjacent nodes of E, B, C, D and F. So out of this, B already comes here, C already comes here, D already comes here. So you just give only F as a adjacent to E. But what is our condition for Hamiltonian circuit? Finally, we have to reach to the starting vertex. So now you see, is there any direct edge from this node F to A? So there is no direct edge. So this solution is blocked. That means this is called as dead node. So this is not the solution. As this direction has reached to the dead node, so backtrack and reach the node D, because this path does not lead to a solution. So backtrack one step back. So then is there any other possibility? So now D is connected with the F. So now you find the adjacent nodes of F. So if you see the adjacent nodes of F, D and E, but out of this already D is visited, so E is said to be visited. So you just give the node E here, but as we have visited all the nodes, finally we have to return to the node A again. Is there any path from E to A, that is direct edge from E to A? There is no direct edge, so this solution is also blocked. That means this has reached the dead node. As these paths have reached dead node, backtrack and reach node C, and there is another adjacent node to be explored, that is node E. Now you find the adjacent nodes of node E. So adjacent nodes for node E are B, C, D, F. But already in this path B and C have been visited. So only D and F are yet to be visited. Now consider node D in this path. What are the nodes are adjacent to D are A, C, E, F. In this path already A, C, E are visited. So F is said to be visited. So you go to the node F. Now all the nodes have been visited through this path, but there is no direct edge from F to A, because as per the Hamiltonian circuit problem, finally we have to go back to the starting vertex. So this path also leads to dead node. This solution path has reached dead node here. So as per backtracking strategy, go back one step. So we find the node E. So this path has already been explored. So there is one more path that is to be explored, that is node F. So now we have to find the adjacent nodes of node F. Adjacent nodes of node F are D and E, but in this path already E has been visited, so only D is said to be visited. So you go to the node D. Now in this path all the nodes have been visited, and according to Hamiltonian circuit problem, finally we have to reach the starting vertex. So there is a direct path from D to A. So this is the final solution now. A to B, B to C, C to E, and E to F, F to D, and D to A. We got one solution for this Hamiltonian circuit problem: A to B, B to C, C to E, and E to F, F to D, and D to A. So we can backtrack further for the same graph and try to find any other solution exists.